Hello and welcome to the first of these instructional videos for how to do the problems in the quiz app. This first one is level 1 for Ohm's Law, and we have here the first question. Now there's a couple of things you need to know before you can apply Ohm's Law to this problem. The first is that this thing here in a blue box with a big A written in it is an ammeter. It measures the current flowing into the red terminal and out of the black terminal. So this is telling us that we currently have 6 milliamps flowing in this direction. The second thing is that this is an ideal ammeter, and an ideal ammeter has no resistance, so there is no voltage drop across the ammeter. So the voltage at this point here in the circuit will be equal to the voltage at this point here in the circuit. And since these are wires, the voltage at this point here must be equal to the voltage at this point here. In other words, the potential difference caused by this voltage cell here, that will all be appearing across this 150 ohm resistor here. So, what value does the voltage source have? That's going to be equal to the potential difference across the resistor. So, we can apply Ohm's law. Ohm's law tells us that the difference in the potential between the two ends of the resistor, delta V, is equal to the current, 6 milliamps in this case, multiplied by the resistance, 150 in this case. So all we have to do is multiply 6 milliamps by 150, and the calculator in the answer box will be able to do that for me. I just type 6m for 6 milli, multiplied by 150, and that's it. Next question. Okay, this time I've got the voltage across the resistor, and again it's an ideal ammeter. There is no potential difference between this point in the circuit and this point in the circuit because an ideal ammeter has no resistance. So we have the potential difference across the resistor, that's 90 millivolts in this case, and we have the current through the resistor, 2.727 in this case. So we apply Ohm's law in its form that tells us that the resistance is equal to the difference in the voltage divided by the current, which in this case would be 90 millivolts divided by 2.727 microamps. And it's not too easy to type a micro symbol. That's micro for 10 to the power of minus 6. So if you just type U, that will be fine. That's a fairly standard thing to do. Since it's hard to type mu, you type U instead, and everybody will know what you mean, including this calculator. So that's fine too. I think the final type of question that we might get at level 1 is asking us to calculate the current. Here, this is one. Now, this introduces a new component type. This is a current source. This is a component that forces a certain flow rate to flow up through this wire and then out through this wire in the circuit. It will establish any potential difference that it needs to in order to keep that amount of current flowing. In this case, we don't know how much current that is, but we do know that it will be a constant amount of current flowing. This is a voltmeter. It's got a big V in it, so that is measuring the voltage, and it measures the potential difference between its red terminal and its black terminal. So it's actually measuring the voltage at the red terminal minus the voltage at the black terminal, and in this case that voltage is 7.5 microvolts. An ideal voltmeter has no current flowing through it at all. It has an infinite resistance. So all of the current that this current source is forcing to flow must be flowing through the resistor. None of it is flowing through the voltmeter, because an ideal voltmeter has an infinite resistance. So, we know the value of this resistor, and we know the voltage across this resistor, so we must be able to work out the current flowing through the resistor. And the current flowing through the resistor must be equal to the value of the current source. So in this case, I'm applying Ohm's law in the form the current, I, is the voltage across the resistor divided by the value of the resistor. in this case 7.5 micro, and again I'm using U to represent micro, divided by 1K5, which is just 1500 or 1500 ohms. I think that's probably about all the different types of questions you can get at level 1, so that's a reasonable place to stop. Once you've got the hang of these, it's time for level 2.